Hi viewers and welcome to the channel, and today we're answering a viewer's question regarding how you would set up a couple of ball joints in a A2plus workbench or a number of ball joints and modeling those ball joints and creating a simulation with them in there. So this is the one that I've come up with just as a quick demonstration. Now these are very crude ball joints in here. They're basically creating the part design out of a sphere, a cylinder, and that's about it. We'll get into modeling them more authentic way in another video, but I just wanted to get them together and constrain them together to show you how it's done and how to start setting up that animation. If I come in here and drop this and select this one, which is fixed position of false at the moment, fix that one to true, and I can move this now, and you can see how that's moving as well. So you can see those ball joints working there. As I said, this is very top level and there's not too much modeling that's gone into these. They're quite simplistic, and I can show you those if I click on that one and come into the view and come down to transparency. There we go, and just knock that transparency down. And you can see how that ball joint sits in that socket there. So very simple. Again, as I said, we'll model these in a much more authentic way in another tutorial. But this is just to get you up and running with A2plus Workbench and how to create a ball joint assembly. If you like this video, please hit a like and also subscribe to the channel. I also have a Ko-Fi site where you can actually donate to my contributions to the community, and that's at ko-fi.com/mang0. So we're going to create a very simple ball joint for this demonstration, and this is just to get us up and running into the A2 workbench. And for this, if I bring up a ball joint, and so we've got the stud, the ball and the socket. Now I'm going to recreate this in very simple geometry. So I'm going to create a cylinder here, a sphere here, and basically another cylinder for this to actually sit in. And this is just to get us up and running with the A2 workbench and how to get that simulated in there. We'll be going back to this and recreating this in much more detail, probably with the part design rather than the part workbench, and using a revolve to create this stud and modeling this properly within here. So I'm going to go over to FreeCAD, create a new document. I'm going to jump into the part and we're going to create the stud first. So the stud is quite simple. We need a sphere and we'll give that some radius. There's 5mm at the moment, so we'll give it about 8. And also I want to place a cylinder on here. So I'm just going to place this in the front and move this into position, and I'm going to place a cylinder in there. So that's there, and we're going to give that some height. So this is the stud, and we're going to go for about, keep the 2mm radius and go for about 20 on the height. So there we go. So it's very simple stud with ball there, and we're going to use the sphere and control, hold it down to control and click on the cylinder. And we're going to combine those together with make a union of several shapes. So those combined as a fusion there. Now with the A2 workbench, we import the models in there. So we need to save this off. So save as, and I'm going to create a new folder, and I'm going to call this ball joint. And in that folder, I'm going to save this as the stud. So that's that one done. So you can see what level of detail we're going to. We're going to very top level here. So that's the fusion with the sphere and the cylinder for our stud. And now I'm going to create a new document. And this is going to be for our socket. So I'm going to save this straight away. Save as, and I'll call this socket. And it's going to say the same directory as the ball joint. And that socket, we need a cylinder. Now if we remember back to our stud, we can actually come in here and look at our cylinder and sphere in here, which I need the radius from. So that's 8mm. So this is going to have a pocket in here that's going to contain a radius of 8mm or slightly more to house that ball in there. So we come back to our socket, and I'm going to make the radius of this around about 8 point. Well, I need it more, so we can go for 15. And we need a height. I'll go for 15 on that one as well. So that's done. I'm going to create a sphere now. Now that sphere would have gone in the middle of that cylinder, which is fine. And that sphere is going to be the same size as the sphere here. So 8mm. And that will section out a piece inside here that will house that ball. So come in here, that sphere, 8mm on the sphere. Now I'm going to click on that cylinder. I want to see inside it so we can see what we're doing. Come down, look at transparency, and just set that to around about 50. You can see that sphere is inside there. Click on the sphere, right click, transform, and I'm going to bring this up so it just pops out the top. Something like that. So that's all we need. And I'm going to take the one that I want, which is the cylinder, and control click the sphere to highlight those two. So the one that I want is the cylinder at the moment, and I'm going to remove the sphere from inside that, and we're going to use the make a cut of two shapes. And you can see that's been removed from inside there. We've got the cut there. So what we'll do now is place the ball in here when we come to our assembly and add restrictions within this to house that stud. So we can save this socket now, Control S or File Save, and now we're going to create an assembly. So for that we need a new document again, and jump up to the A2plus Workbench. If you haven't got this installed, then you need to come over to the Tools Add-on Manager, and within there you'll find the A2plus Workbench. So there it is there. So just click on that and click Install. If it's a bit old, you can also update it if you so desire. And you may need a restart for that workbench to appear. Once you've got that workbench there, we can jump into that workbench. We've started a new document, and we can import our models. So using the add a single shape out of external file to the assembly, or we can even use the add a part from external file. I'm going to use this one here. It'll first ask me to save it. So we need to save this document, and remember this is the assembly. So I'm going to save that as assemble. That'll do. And now we can import our model. So add a single part, come down, and I want the socket. Open that up. There's one part in there called cut, so we'll choose that, and that's imported in. So that's sitting there. The next one we want is the stud. So we're going to do the same. Add a single shape, or up to the A2plus, and add single shape there, and click on the stud and open. And I'm going to choose the Fusion because it's the only one there. So now that's mobile on your mouse pointer. Now, word of advice here, don't press any up and down arrow keys to move the screen, because you may switch the workbench, because the focus at the moment is still on here. So for instance, if I press down, you can see that the focus was on somewhere else. So it's on this assembly here, and it's actually selected this. If your focus was up here, it would actually change the workbench. So it's best to drop that and then move the screen, and then we can pick that back up by using the move the selected part and move that into place. Now we don't have to move it into the exact place, just move it near. So for instance, I'm going to just place it there, hit OK, and I'm going to select this ball and select the internal of this shape here. Matter of fact, let's select this shape and see if we can give it some transparency so we can see what we're doing inside. There we go, so we can see inside there. So select this ball and then come in, look in the top, and we can select the inside there. Now we've got a number of constraints up here, and I'm going to use the add a sphere constraint here, this one here. We'll go to A2, constraints, and add this sphere constraint here. That places it within that hole, and we'll set that. Now at the moment, if we're using the move the part under rule of constraints and click in there, you can see nothing's happening at the moment. Now the reason being is one of these parts needs to be made static. So we're going to have this part here as the part that doesn't move. So we'll click on that part. This may already be static, so we'll look down. And that's got a fixed position of true, which is correct. That's fine. And this one has a fixed position as false. Now what we need is something else to attach to this, because as you can see, if we try to move this, nothing is happening. Normally if you have a secondary constraint or a secondary item in here, then this will start to move. Now I have made a link arm to attach to here. I can import that in, and I'll show you how to model that in a minute, and I'll show you what happens when I import that in. So we'll import, and I think my link arm is in my test folder. Let's have a look. Yeah, testing and link, and this is just a basic arm, so we choose that one. I'll show you how to make this. It's very simple to make. It's whatever you want to connect to this, and this is just for testing purpose, remember. And I'm going to select this circle here and control select this circle here. I'm going to use the add a circular edge constraint, and that will place it on top of that and then set that. Now when I move this, you see this ball joint move. So we use the move the part under rule constraint, select that, and we can see that's now moving. The only thing is you have to be careful of is that you can go outside of that circle there. I've tried a number of constraints to try to stop that. I haven't found any constraint as of yet, so you just have to be careful when you're creating your model. If anybody can come up with a type of constraint on here, I've tried a number of them. Try sectioning this ball a number of times, place angle constraints on there, and that doesn't really help either. But if someone can find some kind of constraint or way of constraining this, that would be great. I've tried for about an hour to figure out how to stop it from exiting this circle here. But I think you just have to be careful when you're doing your animations and simulations to make sure that it's all connected up properly and constrained somewhere else. So you've got a degree of constraint on that to stop it from moving outside. This link, which I created, was really simple to create. So if I go into the part design, and I'm going to create a new document in there and create a new body, create a sketch, XY plane, and it literally was a slot, and just constrain that to the center like that, like so, and a circle in here, the same size or around about the same size of the connection point, and it was literally a close and a pad to around about 5mm or so, and that's all that is. And we can save that off and import it in. So that's all that link was. Just needed something to attach to it for the demonstration. So I'm going to close that document because I don't need it because I've already got a link in there. We'll just save that assembly. What I'm going to do now is create a secondary bearing in here, add it to the assembly, and I'm going to show you something that you may come across when you're trying to figure out how to connect them together, and some of the errors that you'll encounter and how to solve them. So I want to create another bearing in here. So I'm going to import the same files. So we can go in and go to the ball joint, and I want to insert the socket. Choose that. And I want to insert the stud. Choose that. We'll just place it there. And we want another linkage. I really should move that linkage to the ball joint directory. So let's find the linkage. So that's the linkage in there. Now you're going to come across a problem here because we need to understand how this works. With the A2plus Workbench, everything's one continuous flow. So if I try to start doing the same constraints against this bearing as I did before, then you'll get errors. For example, if I constrained these two together, like so, and use the same spherical constraint in there, you'll see that I've got an error there. And that's because there's not one continuous flow against this. So if I just delete that constraint, hit yes. If this was in here, along with this linkage, which it will be in the end, then we've got two lots of constraints to calculate across here, basically two models. The way to do it is actually build your first bearing, attach it to something, and then that part then attaches to another bearing. We can get these in place and place them on our assembly, but they all have to be attached together in a chain for the simulation to work. So for instance, if I placed another hole here and attach this hole to this stud, then I can attach the end hole to the other stud and then the ball to the bearing socket. In that way it will all work. So we'll just do that. So first thing we need to do is go into our linkage and edit that. So I'm going to open that up and find it. And all I'm going to do is come into the pad, double click on the sketch, and I'm going to take this circle, hit Control C, and just bring it over and connect it up to there. Hit close. That's there. So there's two circles on the end of those, two holes. Control S to save that. And we can get rid of that linkage now. I'm just going to save the assembly. And what I'm going to do is just refresh this parts. So if we look along the top here, top toolbar, we can see this refresh button there. Let's just refresh those parts. Now I'm going to take this circle and this circle, hitting Control and selecting those two circles, like so. And we're going to use the circle and circle constraint, and you can see that's constrained now because this one is under our constraint chain and they act as one. So I'm going to set that, and now I'm going to attach the top circle to this top circle here, circle the edge constraint, set that. Now I can move this, so let's just find it. There it is. So click on that sphere and we'll just move that. I can just move it out and up. Hit OK. And I'm going to click on this sphere here and the inside, control click, and use the add a sphere constraint in there. So let's move that down into constraint now. So those two barriers are there. Set that. Now this one should be fixed position is false, so that's movable. So we can move that by using the move the part under rule there, and just to click on it and move it. Place it here, and what I want to do is fix that position. So fix that as true. So now these are constrained together. So we click the move tool, click on here, and we can move these across those ball joints. So that's working nicely. If one of these moved, it's fixed. So let's make that false. And then we can move that in. So you can see how that's working as well. If you're wondering how this move tool works, just hover over it. It tells you there. So one, hit the button, click the part, and then move your mouse pointer. You don't drag and click, you just click and move. So click on the move tool, click on the part, and I haven't got my mouse button pushed down at the moment, and I'm just moving that into position. Okay, so that's a very simple ball joint. Hope that's helped. And what we'll do is in another tutorial, we'll look at these ball joints and create something in the part design that more resembles a ball joint and add it to our A2plus workbench and get it animated in there. If you like what you're seeing, please subscribe to my site. And also I have a Ko-Fi site where you can actually donate a few pence or a few pounds, dollars, or whatever your currency is. And that's at ko-fi.com/mang0, and there you'll be able to help me fund my site, and all the money that I actually get from any funds will actually get pushed back into the channel. Thanks a lot for watching and subscribing. I'll see you next time.